welcome back. So today we're going to be talking about Jug. So first thing we do, and here this way, today I'm actually going to cheat a little bit. So we are going to create this this conda environment that has Python, and I've chosen Python 3.9, Jug, then IPython, pandas, and matplotlib. So this we'll be using these. So actually here I've already run this, so I'm not going to actually do it. I'm just going to directly activate the environment. And so what's our task today? So today we have here this demo data, and all of this is available on the GitHub link. You just click below, everything's there. And this is, if you recognize the names, you can see that's GMGC, and we had a video on what the GMGC is, and we've had another tutorial video on there. And so the global microbial gene catalog, and this is split into different habitats, and here you can see the files are called head because we just taken the head. So we use this head command on Unix to take the first few genes in the file. So here, for example, let's do the dog, for example. Here this just has a small number of genes, and we are going to be testing the hypothesis that some of these habitats that have a higher GC content than others. So I cannot stress enough that since this is just a completely biased sample from a large data set, because it happens to be based on these completely meaningless identifiers that happen to be at the top. There's no science here, but I think it's going to demonstrate the purpose. Okay, so we are going to be creating this file, jugfile.py. So, oops, I already have it. Jugfile.py, so this is a Python file. And okay, yeah, everything's a little bit slower when I do this live because the recording process itself ends up taking some of my CPU. And so here, this is Python, except that we've imported here from Jug import task generator, and we've added this task generator decorator here to this process function. But other than that, this process function, just imports some things. And then again, we're just going to add this sleep to pretend we're doing a lot of work, and then creates the process, reads the FASTA file, and just counts what it sees, and that's it. And then we're going to process for all of them, and yeah, that's it. So if it wasn't for this task generator little thing up here, this would basically be a very standard Python file, right? So what's the difference here? The difference is that, so instead of running Python jug file, we are going to have to run jug, and then this, as many of our tools, this is a subcommand interface. So we will run jug, execute jug file. And now, and I'm going to run this actually on the background, the tasks are executing, and I can also run jug status, jug file. And we can see 1, 2, 3, there it is. So there's a total of 14 different tasks because we have a total of 14 different habitats. And let's just check this, the data. Yep, we have total of 14. And at the moment, or when 12 were ready, could be run. 1 was complete and 1 was active. So we can check again, more progress has been made. So the interesting thing here we're going to take advantage is that we can actually run multiple of these at the same time. And now you can see that there's 2 of them running at the same time. So I can run another one here. And now you can see 4 of them were running at the same time. And then this ended up finishing very quickly. All right, so that's great, but can we do better? Yeah, we can. So let's go back to the jug file. All right, so all we've done so far is we've created these basic statistics up, and you can also see these outputs are now there. So these 14 different. Okay, so what would be the next step? So for here, let's take jug file number 2. And jug file number 2 starts more or less, well, actually almost identical to the first one. And then we are going to actually compute this GC fraction here. So we're going to call the second function that takes the input of the first function. And so now what's happening? Okay, so we can see, first of all, now this is a little bit more complex because we have this process option task that's ready, and then but the GC fraction tasks, they have to wait for the output of the first one. So when we run it, we can see, let's just count 1, 2, 3, 4, and we can see that, okay, now one of these finished, the other one was finished, and so this can go on. And again, we can run multiple ones at the same time. So in my case, I have 8 CPUs, so I'm running 8 CPUs, 8 jug commands at the same time. Well, I'm also running the video, which maybe was not a great idea. All right, and so now this is done. Sorry. Now this was done. Everything's done here. So the other thing I can do is I can run the shell. This is also why I needed to install IPython, is to have access to this shell subcommand. And in this shell subcommand, I have, oops, sorry, I misspelled there. I have access to this environment. So I have these partials, and I can use the value function to load the values, and it's going to take a while, but there it is. So partials, I mean, this is what it is. So this wastewater had on average 49% GC, whilst the soil had 54 and the pig gut had 41. I cannot stress enough how this is completely a toy data set. These results would not hold if we were using the full data set. I mean, I will leave that as an exercise to the reader. I mean, you can check our GMGC videos to find out where to get all of the data and actually run these analyses properly if you want to. Okay, so the next step, where we jug file 2. So instead of actually doing that, let's do something a little bit different, which is we're going to override jug file 3 with jug file 2. So that now, there. Now, so the beginning stays more or less the same, but at the end we add this other step where we're going to put everything together, build a table. So now if I run status, all of the previous results are still there. We just have a new step. And so, and this is one of the advantages of jug, is that if you are, as you're developing your analysis, if you add more steps, your pre-processing steps are already pre-computed and saved, and they can be reused. And so now if I just want to add one more step, it takes, instantaneous. Again, this makes a lot more sense if you had thousands and thousands of CPU hours here, because now, you could just add one more step. And, taking this to the extreme, if I take, so here, jug file 4 adds, a plot where, if I now add it, it's going to create a little plot, which I am, let's see, how do I add this? Takes a little bit. Let me just check what's happening. I can check the status. Oh, there it is. Status, and yep, there it is, this plot. And okay, so, and let me show it to you. And again, I cannot really stress enough that this is just a joke, where we are going to be taking, let me just find the window. Okay, there it is. Okay, this was way too big. But yeah, there it is, the window where this is the output of our analysis.
So you can see that at least in this joke data set, wastewater does have a little bit higher GC content than for example, the marine environment. So again, please do not take this seriously as a result, but please take JUG seriously. It's become, for me, I developed it just for my usage, and it's become one of the most essential tools in my workflow. So, and if you have any questions, we have a mailing list for JUG. We have, you can email me, you can join our Discord channel, or you contact me on Twitter DM. We can even do a Zoom call. So anything at all, we're just happy to help people who want to use our tools. And so subscribe to the channel, and I hope to see you soon.